What's going on, guys? Let's see how we can do this question right here. The question is asking to find the surface area of revolution of this region given by this expression, right? And they have given that this is rotating around x-axis. So whenever we have the surface area rotating around x-axis, we have to use this formula. A is equal to integral 2 phi y ds. If it's rotating around y-axis, then we use 2 phi x ds. So that's the difference. And let's see how we can find it. So first of all, we have to find ds. ds is similar to arc length. It's actually arc length, right? We have to use the arc length formula to find the ds. So ds is going to be, if you remember the arc length formula, we are going to use square root of 1 plus, and here we can write this one in terms of y or x. Both way it's possible. Let's try writing in terms of y and see what happens. And if I take y in terms of y, this is going to be g prime y square dy, right? So if I want to convert this one into y, I have to find x is equal to what value. So here we have y is equal to root x, but x is equal to y square, right? If we square both sides. So this is going to be x is equal to y square. Now we have to find the x prime, that is same as g prime y. X prime is equal to, so this is x prime is equal to 2y, and now we have to plug this one right here. So this is going to be square root of 1 plus 2y square dy, and that's going to give us 1 plus 4y square dy. Now let's go ahead and plug it in this equation. We know that everything else except, so let's plug this one first. 2 phi y instead of ds, we are going to plug this one. So this is going to be square root of 1 plus 4y square dy. Now if you notice, everything except y is going to be a constant because dy is our differentiation, right? So everything except dy is going to be constant. So here we are going to have 2 phi in front. And then limits of integration. So when we write everything in terms of y, limits of integration also should be in terms of y right here, y-axis. So here, if you notice, starting from 2 and finishing at 3, it's given 9 to 3. When x is equal to 9, y is 3. When x is equal to 4, y is 2. So it's going from 2 to 3. So that's going to be the limits of integration. So this going from 2 to 3, and then we have y right here. So we can keep it as it is, y, and then we have square root of 4y square, square root of 1 plus 4y square dy. If you notice, the derivative of this one is outside, so we can do the u substitution right here. So we can pick up u value as 1 plus 4y square, and if you find the du, that's going to be 8y dy. Right, but we have y dy, we have to replace y dy. So let's change this one into y dy. So this is going to be du by 8, that's going to be equal to y dy. Now let's go ahead and write everything in terms of u. So here we are going to have 2 phi in front, and then that's going from 2 to 3, but when we do the u substitution, it's better to write new integral, new limits of integral, because that way we don't have to go back and substitute this u value again. We can directly solve it, right? So let's find the new limits of integration. To find that one, we simply have to take these values and plug it in this u equation. So here the lower limit is 2, so if we plug it here, this is going to be 2 square, that's going to be 4, 4 times 4 16, plus 1, that's going to be 17. So the lower limits of integration is going to be 17, and upper limits of integration is going to be, if you plug 3 right here, 3 square is 9, 9 times 4 is going to be 36, plus 1, that's going to be 37. So upper limits of integration is 37. Now we can plug everything in terms of u. And first one, we know that 1 plus 4y square is u, so we can write in the square root u, and we know that y dy is equal to du by 8. But 1 over 8 is constant, so we can move it to front. So this is going to be 2 phi over 8, and du is going to be right here. Now I can write this one, square root of u is same as u power half. So it's better to write that way so we can see clearly. So this is going to be 1737 u power half du, and 2 pi over 8, that's same as pi over 4. And if we integrate this one, that's going to give us 5 over 4 u power half, 1 more to the power, that's going to be u 3 by 2. So u 3 by 2 divided by 3 by 2. Instead of dividing by 2, I plug the 2 in top. So here we are going to have 2 and 4 cancels. So this is going to be just 2 right here. And then this is going from 17 to 37. And then if you simplify this one, this is going to be 5 over 6. And we have u power 3 by 2. So if you substitute 37 for u, this is going to be 37 power 3 by 2 minus 17 power 3 by 2. And that's going to be the surface area of this region. And that's how we do these kind of problems. I hope you guys find this video helpful. See you next time.